Well, here we have a record playing device. As you can probably tell, it might actually win an award for the world's ugliest record playing device. This thing was built by Motorola, and it does not have a built-in amplifier or speaker. You're probably thinking, okay, well, it plugs into the phono input on the back of a radio or amplifier. Well, no, it doesn't. It doesn't have that type of connection either. Well, you're probably asking yourself, well, how does it work? Okay, actually, this has a built-in low-powered AM transmitter that is designed to transmit the audio from the record to a nearby AM radio. You're probably asking, well, why do they ever make such a device? Well, I'll tell you. To start with, these types of units were popular during the late 30s, early 1940s, and they were designed to be used with radios that did not have a phonograph input jack. It's a convenient way of making your standard AM radio, making it into a radio phonograph combination. Yes, many radios it's possible to add a phono jack, but some radios from the 30s have, shall we say, weird designs where the volume control is not in the audio chain, it's actually in the antenna circuit, so that would make it a little bit more difficult to add a volume controllable phono jack to the radio. Although you could do it, you just have to have a separate control. So, you know, that's where these little wireless record players come in. You know, you can just sit the record player close to the radio and it will transmit a signal to the radio wirelessly. Okay, let's fire this up and see what happens. Okay, we're rotating. Obviously this platter is messed up, but I'm not concerned with that now. I just want to get it to transmit. And we actually are transmitting a little bit. You can hear the radio here picking up the carrier frequency. And when I kill the wireless record player,
boy, that kills me for today. I'm done.
So yeah, this thing is at least somewhat working, but we're going to open it up and make sure it's working correctly. Here's the original power cord, which will be replaced because it's cracking in some places. This is actually a 3-wire cord with only 2 wires used to provide power to the unit. This 3rd wire here is the actual transmitting antenna. Here's the underside with the bottom cover removed. It's a 2-tube unit, as you can see. On the right we have a type 76, which is a triode tube. On the left we have a type 6K6. Here's our schematic. Unfortunately, this set uses a power transformer. The type 76 triode tube is used for a rectifier. They actually have the grid and plate wired together, so it functions as a diode. The only reason I can come up with for Motorola doing that is because they probably got a heck of a deal on type 76 tubes, so they decided to make that particular tube work for them. And our 6K6 tube, that's our RF tube. We have an oscillator circuit here to create our carrier frequency, and then that carrier frequency is modulated by the audio output from the pickup cartridge, which is probably bad, but we'll worry about that later. For right now, I just want to get the transmitter to work. Or actually, the transmitter is already working to some degree. I just want to make sure it's working properly. Okay, here's the underside of the chassis. Not much in the way of capacitors that need to be replaced. Just a couple of paper capacitors and one electrolytic filter capacitor. And we have these old 1930s style dog bone resistors that are often way up in value, so we'll want to check those. This trimmer capacitor here is what we use to set our transmission frequency. Normally what you would do is see on the schematic here, yeah, frequency range 1300 to 1750 kilocycles. So what you would do is find a unused spot on the radio dial within that frequency range and set your trimmer here to the correct frequency on your radio dial. Okay, let's go through this thing and make it work again. Okay, there were only 3 capacitors to replace, and I've replaced all 3 of them. This one, and this electrolytic. The original electrolytic is right here, and as you can see, it's a great deal bigger than what the modern replacement is. In fact, this old capacitor was shoved back behind here. But due to the small size of the new capacitor, I was able to put it here. Now let's check these 3 capacitors and see what kind of shape they're in. First, we're testing the electrolytic capacitor, and we're not even getting any eye deflection when I rotate the dial, so that means that capacitor is basically open. It's not even showing any leakage here. Yeah, a little flicker then, but nothing astonishing. So yeah, that capacitor is shot. The 0.1 is giving me a very fuzzy eye opening at around 0.3 microfarads, which probably means this capacitor is leaky. Yeah, you can see the light flashing violently there. Yeah, it's very leaky. Now the 0.01 is giving me very, very slight eye action. In fact, it's probably so slight that it's not even showing up on the camera. Capacitor is not open, but it's obviously major league leaky. But yeah, I'd just like to demonstrate that what I'm actually removing is indeed bad. I don't want you to think I'm replacing good parts just for the sake of it. Now next we'll replace this power cord. Now I don't have a suitable 3-wire cord handy to put on here, so I'll just use a standard modern day brown 2-wire power cord, and I'll retain the 3rd wire for the antenna. Okay, here we are back together and the new power cord in place. For the time being, I just have the antenna taped to the new power cord. Okay, here we are. We're obviously picking up the carrier frequency. Now, let's see if we can pass an audio signal through this thing. Okay, we're getting a little modulation, but this old cartridge is about dead. That's what you're hearing off the needle. Yeah, I'm hearing a little bit coming through the speaker. So let's disconnect this cartridge and feed it with another source and see what happens. Here's our old cartridge. According to the schematic, this is a magnetic cartridge, which surprises me, but I'll take their word for it. Anyway, reading across it, it reads 1.1 k ohms, which leads me to believe it probably is a magnetic cartridge. But I believe it's dead, so what we're going to do now is just feed a signal into the cartridge input and see what happens. Okay, we have our headphone jack of our FM radio plugged into the phono input of the transmitter. And as you can hear, we're passing a signal.
With a happy meal in his booster seat, knowing that he couldn't have a toy till his nuggets.
And that's over modulating there.
I hit my brakes and mumbled under. Injuries are being reported, and that's why we took our.
Try to find some talk station. I don't want to get dinged for copyright here, which is totally bull crap, but.
Because we're not going to be able to effectively manage any of the problems that might come about if they don't report them. So if anybody's listening and you get one bit of knowledge from this home campaign.
Yeah, that just proves that our pickup cartridge is bad.
Any symptoms that you may, if you take a hard lick on the seal?
But for now, until I can either have this cartridge rebuilt or come up with something else, that's about all I can do to this. And one thing I could do is add an auxiliary jack to the back of this set, and that way, even whenever I get the phonograph cartridge rebuilt, I can still use this unit for a transmitter to transmit line level sources throughout the area. Now the range on this is probably not going to be that great. You know, the transmitter is going to have to be very close to the receiver. Okay, here's our commercial broadcast station.
Ed Williamson, attorney-at-law, SMI Automotive, Rick
And that's us.
on 106.9, The Eagle. She's unique. She's brilliant. She's beautiful.
Yeah, not bad for a little cheap transmitter.
All these things.
And just for the heck of it, I connected the oscilloscope to the audio output of the radio, and for optimum performance of the transmitter, we're driving it with about approximately 4 volts peak-to-peak audio coming out of the radio, so that's about the signal we need to coming out of this cartridge to drive the transmitter to peak efficiency. Okay, that's about all I've got for now. Thanks for watching, and more to come later.